This video will be dealing with the rationalization of denominators. We need to rationalize denominators when there's a radical in the denominator. To rationalize, the first thing we need to do is factor the denominator to its primes. Factorization is always a good thing to do, and it's essential in this situation. Once we factor the denominators to primes, then we're going to ask three questions: want, have, and need. The first question, the want, is going to be answered by the index. So that is easily discovered. The second question, have, is answered by the powers. Easily answered. The third question, the need, is answered by the index minus the powers. Simple subtraction. Also easily answered. Let's take a look at how those all work in action. Let's say we have the fraction 6 times the 4th root of 10 divided by the 4th root of 1323x. Now, the 4th root of 1323x is not a rational number. We want a rational value in the denominator, so we want to find a way to make that denominator rational. And the first thing we need to do is factor it down to its prime. Let's see what's involved in that denominator. So 1323 is 9 times 147. 9 is 3 times 3, and 147 is 3 times 49, and 49 is 7 times 7. So the prime factorization of 1323x is 3 cubed, because there's 3 3's there in the prime factorization, 7 squared, because there's 2 7's, and then of course x to the 1, because there's only one x. So we do our prime factorization to figure out what factors are involved in our denominator there. So there's our prime factorization: 3 cubed, 7 squared, and x to the 1. So the first thing we want to do is make a chart. Our chart is going to list our factors: our want from the index, our have from the power, our need, which will be the subtraction that I mentioned, index minus power, and then the multiplier. First, we fill in our factors. Our factors are right there, the 3, 7, and x. Now the factors 3, 7, and x are going to be multiplied together later to form our new denominator. And we know that this is going to happen because that's what we're trying to accomplish. We're trying to get a 3, a 7, and an x to come out of that radical and become rational. So if that's what we're trying to do, then that's what's going to happen. So our denominator at the end is going to be 3 times 7, which will be 21, x. We already know that right here at the very beginning. Our rationalizing the denominator process already knows the answer for the denominator of 21x. We know that's going to happen. The question is what's going to happen to the numerator, and that's what the rest of this is going to figure out for us. What's going to happen in the numerator. So first, after we fill in the factors, we want to know the want. How many do we want of each of these to pull them out of the radical? Well, that's answered by the index of 4. This was the 4th root of 1323x. Next, we have to put in the powers. How many do we have? Well, we have 3 3's. It's up there at the top of the screen. We have 2 7's, and we have 1 x. So we put those in place. 3, 2, and 1. So how many do we need? We do the subtraction. 4 minus 3, 4 minus 2, and 4 minus 1 means we need 1 more 3. We need 2 more 7's. We need 3 more x's. And that gives us our multiplier. Remember that we're dealing with the exponents here, right? So we need 1 more 3. We need 2 more 7's. So that's 7 squared and x cubed. So it's 349 and x cubed. Remember, 3, 7, and x, that's going to be our denominator. And now the 349 and x cubed is what we're going to be multiplying our numerator by. So if we put it all together, now that we have everything figured out, we have our original fraction here. We multiply the numerator by the multiplier. That's why it's called the multiplier. 349 and x cubed is 147x cubed. So that's going to give us that fraction there. Technically, we're doing the same to the top and bottom, Right? We're doing the same thing on the numerator and on the denominator. But on the denominator, we already know what's going to happen, right? We knew that from the very beginning when we saw the factors. So we can really just write down the denominator. You can do the multiplication if you want, and then simplify that new radical. Or you can just know that that's where it's going to go. We know it's going to be 21x, so we can just write down the 21x. And we end up with 6 times the 4th root of 1470, 10 times 147, x cubed, over 21x. And then always reduce the 2 and the 7 from the 6 and the 21. That's it. That's rationalizing a denominator. If it's a monomial in the denominator. Sometimes, however, it's a binomial. It's okay. This is actually even easier than a monomial. Don't panic. You'll do just fine. We're going to use a conjugate, and you probably have heard of that before. A conjugate creates a difference of squares. When you multiply two conjugates together, they're going to create a difference of squares. So remember when we factored a squared minus b squared into a minus b and a plus b? We can turn that around. We can take a minus b times a plus b and make it a squared minus b squared. That's what using a conjugate is all about. A minus b and a plus b are conjugates of each other. The same terms, one's added, one's subtracted. So if we had 8 over 5 minus the square root of 3, we have a square root in the denominator. We need to rationalize it. But since it's a binomial in the denominator, we need to use a binomial. Monomial is fixed with monomial, the way we did with that chart, the want, have, and need. But a binomial is fixed with a binomial, in this case a conjugate. The conjugate is going to be 5 plus the square root of 3. And of course, whatever you do to the bottom, you do to the top. And when we multiply that together, we're going to get 8 times the quantity, 5 square root of 3 plus square root of 3. But we know that the new denominator is going to give us 25 minus 3, because the conjugates are going to create a difference of squares. You can FOIL that out if you want to, or you can just trust that that's where it's going to go. It's going to make a difference of squares. 5 squared is 25. Square root of 3 squared is 3. Then we work it. We get 25 minus 3 is 22. And, of course, always reduce the 4 and the 11. That's rationalizing a denominator when there's a binomial. This is not complicated or scary or difficult. Just follow the steps one at a time, and it will get you there. Sometimes you need to rationalize the numerator in textbooks. This is actually a rather rare occasion. It's the same exact process, same but different. All you do is, instead of doing things to the numerators, do them to the instead of doing things to denominators, do them to numerators. Whatever you did to a denominator, do it to a numerator. Just flip everything over. It's really not worth worrying about. Okay?